How's it going, everyone? Welcome. Eulier Gonzalez here, and today let's continue now. Make a quick recap of how do we get here, and as we move on and then read the chapter 3, which is more interesting and what I want to dedicate my attention in today's video, is to first look at this book written by Kyle Simpson, a software engineer that has 20 years of experience, and now he actually talked to me, not directly, but through it is writing, when we as JavaScript developers, we need to be competent. And in order to be competent, we need to understand how this tool works, know what it should like. And because the way how JavaScript emerged, it was more like a hobbyist activities that as the year passed, it becomes now a serious business, as it should be. Like anything in life, everything evolved, everything changed, for the better or for worse, but everything changed. So here in this book, at least they get started, is when it comes to describe is first, what is JavaScript? Who makes JavaScript? Why we have the name JavaScript? And who owns the trademark of JavaScript? As well as who oversees the JavaScript or the technical specification known as EsModules 262. And what this group actually does in this commit, what are the activities that this commit does, and where they promote certain champions or proposal to way up all the way up through series of stage from 0 to 4. And this something that can take weeks or months or even years. And despite that, some of these JavaScript implementations, like the browsers or now the server, some of them may decide to not follow that due to the legacy reasons, because the end goal of the TC39 is to avoid break the web. So in order to do that, they need to guarantee this backward compatibility. That is, so for example, like Polyfills or machines, where they provide now this snippet of code in JavaScript to say, hey, if the browser or this environment doesn't support these particular features, this is a shim here. So because the TC39, despite that this is a group of people that works in several related web industry, such as browser makers or device makers, so on and so forth, they don't know the reality of the web because it is vast, it is huge, and some of them, and sometimes it precedes some of them. So because the browser who actually knows, or the browser implementation who knows the reality of the web, sometimes they can decide to not go or they can decide to jump in the spec as again as a way to provide these legacy features. So for example, there is a common drama and funny things that happen in the JavaScript community, which is the Smushgate, where the TC39, despite that it is best efforts to provide now a particular feature called flattening, right? Since there is already a library that we're using that particular name in the arrays, and not only that is also making some dumb operations. So because of this, they have to go back to the drawing table and then change that name to flat, right? And this is just one example of this. But despite of that, all of these JavaScript engines must stick to the law. And because there is a diversion between the reality of the web and the spec, okay, which is similar to what happens to a lot of JavaScript developers. Uh, so, and especially if you're working for several of these collect environments, okay, whether it's a browser, the server, light bulbs, robots, you name it, the only reality that matters is the web. And because the web, for example, here when you are using is the console or Devtools, right? This is a JavaScript friendly environment, not a strict JavaScript. This was not meant to be developed for that. It was just to help JavaScript developers with small, simple tasks or some small set of instructions. So a good example of this is the way how now uh, the uh, the console actually works or does behind the scenes. So for example, it actually add the when you define as a functions, when you do a function declaration or or a variable, okay, all of those are now attached to the global objects and append their name as a props and their value onto the window object. So this is not what happened really in JavaScript uh, because all of these variables they don't are appended to the global scope. So for example, right? In as well as there are other several stuff. For example, like the user strict. So user strict now is per file, where now here you're using is user strict is per season. So this differentiate or this difference is just to understand that the JavaScript console log that you have in the dev is just a friendly environment. It's not a strict JavaScript engine. So but besides that, okay, the way how the JavaScript engine works is like a compile, and this is the way how the JavaScript engines now treat or deal with errors. So because there is a even you can look at that at the spec and test that in the JavaScript friendly environments like the console, where it performed this syntax semantics, all right, where some of them is for early errors. So a good example of that is when you define is well a good example of this is, for example, when you define is variables, right? Say this is my name, and when you define variables that are not consistent like this, it will now throw you a syntax error, all right? As well as among other syntax errors that can happen there, you can take a look at the spec to understand one of them or a couple of them, right? But because JavaScript now have this parsing phase, which is something that happened in a lot of compiler language, when they have now this compile phase, and in this compile phase, you now take this set of instructions, you tokenize this by putting is all of these different keywords operators into this bucket, all right? And then you now define is the relationship among them using now an abstract syntax tree. So by taking all of this token and then convert that into an abstract syntax tree, a map to see the relationship between the name, the identifier, as well as the specific statement. So for example, in this case, what is the var, which is a reserved keyword, what is this is doing similar for what is this, the identifier. This is an assignment expressions where it's going to now try to take this string value as here and then assign that to, right? So all of this relationship that happens among all of these different tokens, okay, different tokens, is what is creating in the abstract syntax tree. And then that is usually compiled into a binary representation of the code in that distribution that can be well distributed across different distribution in that across different in that can be distributed across different computers using that same distribution. So what does it mean? That is, when your JavaScript files leave your IDE, all right, it's gonna be transformed into some browser safe JavaScript code, which is quite different of what you wrote, which is usually is following is the latest syntax of the JavaScript, which is something that is promoted by the community, all right, to get the benefit of this. Then that code will be transpiled into this browser friendly or browser safe code that is going to be bundled up, whether it's for Webpack or Vite or any other model bundler, all right, that is ready for delivery. So when the JavaScript engines, in our case the browser or another engine like the server, it receives that JavaScript, it's going to parse that, and then it create now some intermediate representation of binary code or bytecode, right? That is gonna be inside of the JavaScript engines, pass through the compiler for further optimization until your code is ready to execute it, and then it go on. So all of this is just to describe that process and how important it is for us to do that, because as we do that, we can now understand what JavaScript is doing behind the scenes, or most of the time what this engine is doing behind the scenes. And because now there are these particularly hints that we pass to the JavaScript engine known as strict mode, to that it changes the semantic, but is act as a guide for developers to that act as a guide to developers to indicate the JavaScript engines to run optimizations in this is something that doesn't stick to me, and I want to know why it doesn't stick to me, okay? Because this is strict mode, okay? So this strict mode is instead of looking at this as some sort of constraints that limits you, this is some guidelines the developer. This is some guidelines for developers to that. This is some guidelines to developers that. This is some guidelines. This is some guidelines for developers that provide good hint, or that provides JavaScript hints. All right, I will say this is that provide JavaScript is hint, or that provide JavaScript that provide JavaScript a best chance to optimize and effectively running the code. This is interesting that it's a best chance, or to provide, it's because there is no hint, because this is now the way how you should write this JavaScript code, and as a developer you have to do this because the JavaScript engine now has a best chance to optimize. So the JavaScript has a best chance to optimize and running your code efficiently, okay? So the JavaScript engine has the best chance to running so has the best chance of optimizing and running the code. But this is just some guidelines, all right? This is some guidelines that provides that this is some guidelines that developers must follow, uh, that the engine can so that the engine can okay so that the engine hmm, so this is some guidelines that developers follow. This is some guidelines. Yeah, this is some guidelines. This is a guide uh, to the best way to do things. Okay. Hmm. This is a guidelines for developers to do the best things, so that the JavaScript engines can now has better chance to running. Exactly, has a better chance of optimizing and running your code. So for example, here when we use a strict like this, all right. So this chance of JavaScript for optimizing and running your code when you use a strict is like this. So for example, you say, hey, you can use inside of a function, or the value of inside of a function here, the value of this, right, inside of a function is not window, is uh, is nothing. All right. Again, this is some guides. This is some guidelines to do. This is some guidelines to do the best. This is some guidelines of doing the best way. This is some guidelines to do things the best way for developers, so that the JavaScript engine has a better chance to optimize, so that the JavaScript engine has a better chance of optimizing and running JavaScript code. So for example, you got things like this. Uh, yeah, so for example, you got things like this. So the use strict. And the other is this. So you got for example use strict, function name, so on and so forth. Okay. Give me a chance. I'll be right back. And we're back. So this is the strict mode. And another thing of the strict mode is to say, hey, which I do find quite interesting, and more relevant. So for example, to say, hey, if you find, for example, is the name of the function eval or arguments, all right, please do not. Please throw an error, right? So for example, like this, say, hey, no, and then you say eval. It say, hey, you shouldn't have any of this eval or arguments in a strict mode. So for example, if you use eval, this eval function, what it does, which is a very obscure functions that it quite be useful to execute some JavaScript statement. All right. So for example, here eval, I do think is something like this. You say, hey, var, or you can say console log here. I am. Let me do this. Say, hey, I am. I am an eval console log, right? We can do much better like this. Something like this, all right. Eval error, refuse to evaluate a string as JavaScript because unsafe eval is not allowed source of a script involving content security here. But here is because the clients refuse to go with this because it say, hey, I am running a code that is not allowed. You know, I shouldn't run this code. I shouldn't go with this code. So a good example of this is this one. But the thing here is that this eval, which is a function that we have in JavaScript to evaluate that kind of expressions, here we cannot even run here in this console because the virtual machines, the JavaScript environment here, it say no, I don't trust the code that you're gonna write, so please no, you know. Is this content security policy directive a script source GitHub get access here, and he say no, I'm not going to evaluate that kind of expressions. So but the thing here is eval allow you to do this, and this is the reason why is now use strict is this guide to do or is this guidelines of what is the best way of doing things that has a better chance for JavaScript of optimizing and running your code. And this kind of optimizations is, well, for example, you can rewrite a particular function that exists, a val or arguments, or you can have access inside of this as the or the value of this function inside of a function expression, it is undefined. So we are actually helping you in doing that. So there's some assumptions here and some optimization that is doing this, and then on the on the topic of describing that JavaScript at the end of the day, or the people around that has concerns about has concern about if JavaScript is fast enough when it comes to parsing and executing the code. ASM.js actually showed that it is possible, and then now you have this successor spiritual, which is the WASM, that say, hey, instead of actually is trying to optimize the parsing phase, let's going to skip the parsing phase by creating this intermediate representation of the language that will now allow us is to run the code in this environment. So we can now pour code from C, Rust, Java, and any other language into this intermediate representation that is be ready to be executed at this WASM environment. So I think that this is quite is go beyond the scope of today's video, and I do think that is quite interesting, quite compelling that is the case. And then when serving JavaScript here, I'm gonna make a quick recap here of this, which is that each program or each file is a program, right? So despite our intuitions that we can think that on an application or a web app, all of the JavaScript act as a single program, this is not how JavaScript see things. And the only way that a JavaScript, different standalone JavaScript programs works together if they share the same state, the global state, or if they are sharing its public data and functionality in that model that can be used by others. So in the case of EXSystem or models, since again, whether it is an import or a script, the thing here is that these files only act as a single one at runtime due to the interoperability of, in the case of JavaScript files, importing these files, right? But in other words, it is safe for us to think that these JavaScript files work as a single one. Good. Now, then we look at inside of these programs, we have values. What are the type of values? We have primitive, and we have objects, and how now this object and how now this primitive or these values allow us to manage the internal state of the application or the program, okay, by using now several of these representations. So whether it's a string, whether it's a number, and each one of them follows specific spec, right? Uh, then you have now big int. We also have booleans. We have two values. Then you have is the kind of emptiness, right? Whether it's null and undefined, and their use cases, and symbol for private hidden values that you only want to have access, okay? Uh, and then now we have these objects, and how the objects, all right, is the way of how you can describe is collections of values as a tuple or as a list in a numerically indexed order, in a numerically indexed sequence, all right. And the other is the hash table or the key map, which is just like we can think of this as a like a spreadsheet, all right? When you have now the key, the identifiers, as well as the values, and because these values can be is all of the primitive, as well as a collection, as well as an object, and also a function. So when you want to determine the type of value in JavaScript, which is the way of how JavaScript say, hey, this is a value, all right? In the case of primitive, the only thing that is counterintuitive is the null. So no problem with that. But the other thing that is quite counterintuitive is that functions are values. And now functions act as a value. This will unlock now a series of techniques that we can go and use in the functional programming. So because now in JavaScript we can use is the procedural functions or object-oriented programming, okay? When we look at these function values that can be or that is a value in itself, because these values can be represented as a literal or held in a variable, all right? And a variable is just a container where these containers now allow us is to determine is how widespread this value is across our program, okay? So because the var here in this case is or the variable has different syntax form where each one of them has inherent properties, we have now is, for example, the var that is per globally and per function. We also have is the this is var. We also have is let, which is a more constraint, and it is a block scope. You can is redeclare, but you can reassign values. In this particular concept of redeclaration and redeclaration and reassigning is quite crucial as we understand as we develop the intuition or the understanding of the variables in itself. So we have now let, we also have now const, okay? And how now const is a more strict, and it say, hey, you can is redeclare or reassign this value after this block, after later on in this block scope, all right? However, you can mutate that value. So this is part of the quirk in const. The other places where we can define its variable is with functions definition, where the association between the identifier and the value happens is at compile time or at parse time before executing, and then you have now the function expression that happen is at execution when that line of code is evaluated. Okay, so all of this is just to um, go deeper into where you can define and using variables, and when you use try catch actually is in the catch error that allows you to have access to these variables there. So because now this is how you can now hold values, and since functions is a value in functions, here the term is quite spread, quite broad, because you can use this as a procedure by defining is a series of statements, all right, where this can be run once or multiple times, all right. So for example, some configuration files, and also you can use is the strict mathematical definition of what a function is. This set of rules that must strict abide. Now, this nature of the function, as well as how you can define this function inside of the language, which is whether it's by declaring that functions or as a function expression, all right, this will open up a new discussion about how functions actually works, and what is the role of this function at the end of the day. And I do think that is very important to understand that, or to create this reference, because now functions can be used as value, whether it's in an array, okay, or in an object, okay. And when you define this function in an object, like a key value pair, it also now unlock other series of computation or pattern here. So for example, is that we can now is define is functionality, dynamic functionality that happens at runtime. Okay, hey, given this list, or given this table of functions, all right, I want to now is run this when this certain condition, and so on and so forth. So this is talking about the functions, serving the functions. And then when we look at the comparison, which is the equalish and the coercion, here we have is on the equalish, okay, the way of how can we now is a determine that a value is equal to it itself. The language and the spec says that certain values like primitive and also objects, all of them are seen as a identity values. So when it comes to compare that, they're gonna check it is identity, not the content in itself. So for example, is that hey, is 42 is the same as this 42, all right, in terms of it is identity. So you can think of this like some sort of values that you can have, or a good example is like asking yourself if you are you, right? There is only one you you person, okay? And that is exactly what is comparing here. So because values, unlike any other programming language, you can specify is how you can is assign this value or pass around, whether it's by copying it or by passing as a reference. Here in JavaScript we don't have that. The only way to specify is by its value. So primitive values are passed by copying it, okay? Or when you assign this, it's creating a copy of this, and when you now use object, is passing that as a reference. So this is the definition here of the coping or passing a reference. And this is why when you want to or equalize to functions or to values here, it's gonna check first if they are the same type. All right, good. Now we will go to do that comparison here. So whether it's for numbers or strings or values, it's gonna run that. And I do think that in the case of this triple equal, which is something that I would like to dedicate a little bit of time here, the triple equal here, the equal, this is EGMA 2026, right? The equality, equality expressions, exactly. So for example, like this, and runtime semantics, okay? In the case of this, it's gonna perform this loosely equal. Anytime that you look at this runtime semantics, it's actually telling you what it's doing at runtime. So this is what it's gonna do at runtime. So for example, is this, all right? It's gonna check this. It's a strict equal. If they're the same type, so return false. Okay, if same type is false, return false. If this is a number, then return is number equal to actually compare that per number, or return same non-number here, right? And then it's going to evaluate is this, right? If the same type is true, okay, but if x is either undefined or null, so return true. So for example, in this case, what it's doing is, if I'm going to evaluate is this a triple equal, and if this give me is, and if both of them are undefined or null, exactly, then return true. If this is a big int, then return big int equal. If x is a string, then if x and g have the same length and the same code unit, this is also important to understand this, okay? So return big equal int. So for example, if this is big equal, so it's gonna compare this big equal to do this, all right? And it say, hey, this is an asterisk operation that takes these two arguments and it's gonna compare that based on the real values in the mathematical sense, right? If this belongs to the real world or to the world of the mathematics here, then of course I'll go to do this for the case of big int. But when it comes to compare now is strings, if both of them are the same, all right? So what it's gonna do is to say, hey, if the x and the g have the same length, okay, and the same code unit in the same position, return true. And I do think that this is something that a lot of people actually flew over the string and what string it is, which is something that we're gonna discuss that later. But it turns out that it's gonna compare its length as well as its code unit, okay? If all of the characters, so if they have the same length and the same code units in the same position, return true. So for example, whatever character you can have here, all right, whatever character you can have here, if both of them has first the same length and then the same code unit at the same position, all right, like this, then return true. Otherwise, forget about this. And if both of them same value, no number, exactly. And if both of them now, and if both of these are booleans, all right, if x and g are both true or both false, return true, otherwise false. So pretty self-explanatory, you know, and this is true, and if this is true, you know, it's plenty self-explanatory. Same value, no number is actually telling you that. And if x and g return true, note all EsModules values are compared by identity. All right, all of the JavaScript values are compared by identity. Hey, if this value is the same, and when we talk about here now, this is put primitive, and when we talk about here now with objects, all right, since the comparison here happened is not by its content but by its identity, all right, and since now objects here, unless they have the same reference, is the only way that the equality remains the same. All right, in other words, is not by its content, is by the value that they're pointing to. Okay, so if they are pointing to the same value, all right, good, then that means that this is now an object. So for example, say array here, array nums. Okay, you have 1, 2, 3, 4, and since here we can say is array num is equal to array num, so this of course is going to be true. Array num reference error, array num is not defined. Yes it is, exactly. Oh, because it was evaluated? That's interesting. Okay, so it is true, all right, but if for some reason we say, hey, this is array nums, let's say 1, it's different, and then we say, hey, this will be now, I just want this to now, when I'm going to assign or pass a value, if this is an object, it is be passed now as a reference. In other words, so array num, it will be the same as the array num1. It's checking is by its identity. If for some reason, okay, let's see, somehow we mutate this, all right, of course we cannot mutate that, but we can say is this too. If for some reason we mutate this and say, hey, push now is 5, okay, exactly, so is this one, so I want to create now, so I want to is return you this, so push, so for example push in array mdn. I'm just stretching the metaphor here, all right. Oh, it's gonna give you is, that's right, specify the end of the array and return the new length of the array, so it's gonna give you is a new length of the array, okay. And if for some reason you say, hey, I would like to is concat with this another element here, okay, let's say 5, so array num2 is now not only pointing to that, because concat what it does is to create a new array, okay, concat, what it does is to not change the existing array, but instead return a new array, okay? So in other words, array 2, when you compare that to array num, it is false, because now they don't have the same reference. You create a new one. And all of this silly stuff that I mentioned here about the equalities, about the also the topic of the coercions, of what happened when these values here, for example, on the equalities happens here, all right? So for example, what happened here when you're trying to compare differing or looking is or doing a relational operations, okay? Whether it's this or this another relational operation, okay? And then you say 3, all right? So what's happening here is that JavaScript is going to evaluate this from left to right, and it's going to say this, what is this? 1 is less than 2, this is, or 1 is greater than 2. So when you take a look at the relational expressions like this, all right, what it's going to do is to say, in this case, it's going to get the value of both, all right, and then it's going to run the is less than abstract operation. So if we look at this, it say, hey, I'm going to run this from left to right, all right, which is from left to right. In this left to right, it say, hey, I'm going to try to coerce both of them into a number, okay? I'm going to try to coerce both of them into a number. So if I coerce that into a number, all right, for example, like this, which is entering here into the else and say, hey, if both of them are numeric, I'm going to check if they are the same type. Is true, then I want to evaluate is this expression here and return less than this, right? And here is when it's going to call this. And all of this, what it does is to return now a undefined value, all right? So for example, if you do something like this, if you return not a number, not a number, it should return is undefined, but in this case, it doesn't. It return is false. Okay. You know, despite that this is telling you what it's doing, it's not working as it is. You know, it's not returning is the undefined, as you might guess. It's returning is this evaluation here. So what it's doing here is this. So this less than that is telling you now is the algorithm that is following here, right? If both of things are finite, okay, return true if that operation is happening. And what it's doing is something like this. If 2 is greater than 1, yes it is. If 1 is greater than 2, no, it's not. And then, because now this value is a Boolean, and if we go a little bit back to evaluate now this Boolean, and then do something like this, all right, So for example, is so now when it comes to evaluate this, now this becomes is a boolean and this is now a number. What it's going to prefer, okay, is to try to coerce both of them into a number. And if that coerces that into a number, it says, okay, I'm going to try to coerce here is false into a number, which is 0. So 0 becomes, of course, is greater than 3. 0 is less than 3. So what happened when we have things like the other way? All right, this is true, right? And when this is it, you say, is this is as it is? All right. Is this is as it is? So this evaluation returns true, which is 1. And then you say, hey, 1 is less than 3. Yes, it is, right? But the other is that 0 is greater than 3. No, it's not. 1 is greater than 2 is false, right? But 2 is greater than 3, and this must be is there was a very particularly example here with the operators, and you don't know. No, it's not. It is deep dive into the language. Okay. Bitwise operators. No, it is. It is. For example, is this one is less than 3 exactly? It's because I have my mind around. It's like 1 is greater than 3. No, it's not. All right. No, it's not. Three is greater than 2 is true. Is greater than 3 is false. Is greater than 1 is true. Exactly. But when you do things like this, 3 is greater than true is this, and then is 1, and it becomes false, and it's because this expression is being evaluated to true. True is now coerced to a boolean, a number, all right? And that number is 0, and then 0 becomes is this. So the thing here is that this particularly corner cases of dealing with these logical operators, especially with several of these is something that is not be used, all right? Because the way of how now the algorithm is doing. So one is greater than two. No, it's not. But then is three. Okay. But what if we say 3 is greater than 2, which is true, but this is greater than 1, and as you can see, this is when these expressions fail short. Because it's the way how this algorithm is working. So this becomes now true. 3 is greater than 2, so this becomes now true. And the algorithm here, this relational operators, is going to coerce that into a number initially, okay? It's going to coerce that into a number, both of them, if it can, okay? And then do the numeric comparisons there. If this, for example, is a string, okay? If both of them, for example, now are a string, it's going to compare it's going to check the length, all right? It's going to compare is the length and as well as the code unit along the way, right? So if for some example you have 1 and 0, what it's going to do is to compare the code points units there. So this code point is just huge table that Unicode has to say, hey, this segment represent is Latin. This another represent is Latin extent. For example, Slovenian, Romanian, so on and so forth. And this represent is now hand-based characters, Chinese characters, Chinese or Korean, Japanese, Philippines, Laos, and so on and so forth. So this is the comparison what it's doing with strings, bro. With string, bro. With string, bro. And look at this, why this is true. Because what it's doing is one of them is a big int and the other is a string, okay? I want to now coerce that string into a big int. Coerce that string into a big int. String to big int. String to big int. So, and again, it is comparing is by string, you know, it is comparing it by string. It is still doing that string comparison. It is still doing that string comparison here. And now when it detects that both of them are now a big int, it's going to compare that. So, but again, it's doing that comparison per code unit, bro. It's doing that comparison per code unit. The whole point of this is to understand that when these kind of things happen, especially on the equalities and the coercions, right? how important it is for us to understand what's happening behind the scenes, especially with these relational operators, whether it's double equal or the triple equal, or the greater or less than, you know, and get yourself familiar with this, because this might be another quite interesting question, that is, hey, what happened here when you try to compare now, is, or when you want to do the relationship between objects here, all right? When you want to see the relationship between objects here, you know? So if this is greater than that, when you want to compare now, here objects, and again, if we take a look at this, and then we evaluate against this, all right, and then you say, hey, if this is this less than, because it's evaluating is this, it's going to try to coerce that into a primitive. Okay, so it's going to coerce that into a primitive number. Okay, this is the reason why this actually has true. It's gonna coerce this primitive into a number, and since the number coercion of an empty string is zero, right? And zero is greater or equal than zero, it say yes, this is true. You know, but again, this is doing the numeric coercion primarily, all right? So this kind of stuff is just to mention that perhaps you're not going to see that in the real world of this stuff, but it's just to understand that when you're doing this equalities, okay, operations, what is going to check is first the algorithm, all right, the abstract operation that is doing, okay, whether this is a primitive, this is a boolean, and then it's going to evaluating this and coerce its type if there are this depend of the algorithm. So here they less than prefer, usually, as you can see here, less than, all of this, whatever it is going to run is this abstract operation. It's going to run the less than operation, right? And all of those operations, okay, are going to evaluate and going to coerce those into, I'm going to coerce those into a primitive with the hint number. It's going to try to coerce that into a number here, right? Whatever is this, whatever is less than equal, greater than equal, or less, or this, all right? Whatever it is going to coerce that into that. So the point of this is to understand what this relational operator is doing, okay? What is the logic behind the scenes, which is practical and it's real. It's not something out of the thin air. And that recognize that both of them would prefer is the coercion, the conversion of whatever value you pass here into a numeric value here. This is true for this kind of operation. And the other is this loosely equal, the triple equal, and the other is the object dot is, right? What it's going to actually verify is the identity of each one of them. And this is what this comparison means. It's checking its identity. It's checking if the value it is what it is, right? So it's checking if 42 is indeed a 42, right? And if for some reason, each one of them now are different, okay, right? For example, 42 and 42, if one of them now are the different types, it will prefer now is, if we take a look at these, this is the triple relational operators. Relational operators, triple equal, equality operators, like this one, exactly. It's loosely equal, or it's a strict equal. It is both of them are the same type. If same type is false, return false, and it's actually following is a particularly if a particularly, so for example, you have symbol here, you say one value, and symbol here is a value. It's a interesting because here now symbols are again the comparison here is so symbols acts like some sort of objects here. It's a symbol, right? So symbols act here as an object here. Exactly. So symbols here act as an object here. This is interesting. This is interesting. This is interesting. This is very interesting. So the thing here is that as we look at this, and also is the loosely equality, which the loosely equality would say, hey, I will prefer to check if one of them is undefined or null, then return true, right? But if one of the normative optional, if the host is the web browser or other supports internal slot, then if X is an object, X has an is HTML DDA internal slot, and G is either undefined or null, return true. If X is either undefined or null and G is an object, it has an is internal slot, return true. But it's the host is the web browser or otherwise supports the is HTML DDA. But the thing here, this is normative optional. But the thing here is that even though the algorithm now has changed over the course of that. So in other words, is that if both of them here, if both of them are null or undefined, okay, I want you to return is true. However, if one of them is a number and the other is a string, I want you to is coerce that string into a number. I'll prefer you to go to do is a numeric coercion, which is 42, right? Is equal to 42. So what it's gonna do is to try to identify which one of them is the type, and if one of them is a string and the other is a number, it's gonna prefer is the numeric coercion. Okay. However, if now you're comparing it with string and a boolean, it's going to try to coerce the boolean into a number. Exactly. Into a number. So in other words, if you say 1, it's going to coerce that into a number. If one of them is a boolean, it's going to coerce into a number. Interesting. Now, here's when the interesting part kicks in. If one of them is an object, okay? If one of them is an object, I want you to coerce that object into a primitive. Okay, I want you to convert is this into a primitive. Interesting. Hey, please, let's go to convert this primitive. Okay. Let me convert this primitive. If no hint has provided, by default, is exotic to prim is not undefined. If the preferred type is not present, then let the hint is default. And if this is default, if preferred type is not present, let the preferred type be number. In other words, you're gonna coerce that into a number. You say, hey, if one of them is a primitive, I want to try to coerce that into a primitive. I want to coerce that into a primitive number type. So in other words, this numbers will become, so this is like doing this, all right? In numbers, it will become like 0, and then is loosely equal. Return is loosely equal of this. And is loosely equal is going to now evaluate this again. Okay. It's going to evaluate these things again. And now since one of them is a number, okay, and the other is an object, if X is either a string or a number, or if X is an object, and G is either a string, a number, begin, or a symbol, return is loosely equal of, okay, is going to coerce that, okay, is going to, okay, if this is a number, what is going to coerce is the objects into a primitive. So in other words, it's going to coerce this into a number, which is the coercion of the object is not a number. So if you put something like this, it will give you unexpected token. Wait, what? It will give you false. What the French still happening here? Yeah, give me a second. I'll be right back. And we're back. Okay, cool. Now, so this is when it look at this, and it find that in this case it will say, I don't know why it say unexpected token. Unexpected token. That's interesting. What about 32? Okay. Okay. It says unexpected token. Okay. That's interesting. It's because it's expecting like an assignment here. Okay, makes sense. Okay, makes sense. So here, this is a way of how you can tell JavaScript to evaluate this expression. What this going to produce. Okay. Quite interesting. Again, this is a friendly JavaScript environment. It's not the true JavaScript environment. So in any case, this is 32. All right. And when this happens, you have to provide this. And what it's going to do is to try to coerce this object into a number. So what is the output of this? In this case, it's not a number. right? So because not a number is what is going to output here, and this is false, which is the same as of doing this, right? And it is true for it is almost true for arrays, but arrays here, when you convert that into an array, it's give you now 0. So in other words, if you do this if you do this, since it's going to coerce that into a 0, this is false because now it's comparing both of them, which is interesting. Okay, if X is an object and G is either a string number or an S, but if both of them are objects, okay, so if they are the same type, okay, for example this, if they are the same type, now it's not going to enter into the loosely equality, it's going to the same type, and it's going to check if that, because this comparison is by identity. If X is an object and G is an object, return true, right? But because this comparison here it returns a boolean, but because this comparison here it determines whether or not two arguments are the same type, it performs the following step. But because this is from the same type, so hey, are they the same type? Yes, they are the same type. Okay. Yes, they are the same type. It's true. Then it's a strict equal. It's going to evaluate now this. Okay, if they are the same type is true, then it's going to say, hey, if X is a number, I'm going to try to evaluate that as a number. If it's not, return same value number, which is how this same value number abstract operation happens. And that is, I'm going to check if I'm going to assert if they are the same type. Okay, both of them are objects, but know that all EsModules language values are compared by identity. So now the comparison here of the values is not by its content, it's by its identity. That's what happened. And this identity is, hey, they are the same. They represent the same. They're not representing the same. They are different. And therefore, that's what it is. So you don't have any, for example, you don't have any different 42. 42 is the same as another 42. This is what identity means. Euler, it means Euler what it is. Okay? As long as it has the same name, but it means that a human, it is a human. Whatever it is. So again, this goes beyond and more in the mathematical sense, but I do find it's quite relevant, especially as we explore now these relational operations, as well as the equality operation, what the equality refers to, and what the relational operations like greater than, equal than, blah, 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 blah. They prefer is to do a numeric coercion on both operands, right? So when they do this numeric coercion, so for example like this, or for example like this, all right, they prefer to do a numeric coercion of this. So this is some of the things that we have to be aware of. And this double equal is going to check if they are the same type, all right? If they are the same type, the comparison will be is based on its identity. If they are not the same type, is going to now pass through a series of matrix. Okay, so hey, whether this is a null or undefined, if it's true, or whether this is a string and the other is a number, right? Yeah, pretty fucked up stuff. It's going to try to coerce that string into a number. All right, that's why this is true, and the same. It's not the same for this because he's checking out the type. All right. Uh, and is, for example, is one of them is in Boolean. Is going to coerce that into a number as well. So you get the idea. And if both of them now, and if one of them is a in an object and the other is a value, is going to coerce that object into a numeric representation. And this is the numeric representation of an object like an array is 0. This is what it is. But if you do this, it is false because it's not a number. So all of these nuances that happened here is just to understand now the nature of the language, especially when it comes to compare them. Equalities and the comparison or the coercion. And then we went through describing how now JavaScript code is organized here. Okay, whether it's by class or by models. All right, in this case, in classical models, and now we have is the EXIS models. And this is just to mention is all of the things, at least from these two first chapters in this book, that talks about it. And I do find that really very mind-bending stuff. So that'll be all for this video. Take care. Bye-bye.